Hi, in this video I want to show you one of my books. This is Pre-Calculus Mathematics, and it's by Shanks, Brumfiel, Feenor, and Eicholz. And this is an old book. It's super cool. I love this book for multiple reasons. So first, I love the color of the book. It's got those like 60s colors. It's just really interesting. So yeah, that's awesome. Secondly, the smell of the book is phenomenal. It has a very, very unique smell. Someone left a comment a while ago, and they were talking about the reasons for the smell of books. And they gave me a link, and I forgot what the link was. And basically it explains that different math books, have different smells, I think, because of how the paper decomposes. Basically, there's chemicals that decompose, I guess, and they let off a certain smell. But this book has an incredible smell. Anyways, I love the smell, I love the colors, and the math. The math in this book is way more intense than I think the math in more modern pre-calc books. Let's see if we can find when this was printed. I believe it's in the 60s. Yeah, wow. Copyright 1968, 1965. So this must be the second edition. It doesn't say. Yeah, but it should be the second edition because I think the first one's in 65. Wow. So let's look at the contents. I think you're going to like this book. And then let's just explore this book, and I'll show you some of the math in this book. I've read small portions of this book. I'm currently looking at this book. I've been making, or rather trying to make math videos for my other YouTube channel. And so I thought, hey, let me, use this as an opportunity to get some ideas. But that channel is in Spanish, so that's the real challenge. So the plane, it starts with like really basic stuff, and honestly, maybe you haven't studied this stuff. So we'll look at that in a minute. And then vectors in the plane, space. Yeah, let's just go through the contents briefly, and then we'll just jump into the math and we'll kind of explore the book. Vectors in space, cool. Lots of topics here, and a lot of these are topics that you would see in other classes. So compared to modern books, like you could take a pre-calc class or a trig class using this book. That's basically what a book like this is used for today. However, this book has a lot of topics that you won't find in modern books. And I think that's because those topics aren't taught, so there's no reason to put them in the books if they're not being taught. So that's why a lot of modern books don't have the topics you see in some of the older books. Things change. There was a time when spherical trigonometry, which is really cool, I should make a video on that, was taught. And so it's no longer taught. So let's just take a look at some of the math. Let's just jump in. Let's look at some of the exercises to see if we can do them. See, are they hard? So sketch the vectors, add them, and sketch their sum. That's pretty easy. So nothing here is weird. Solve the vector equations. Okay. Very standard stuff so far. I'm trying to see if there's anything different. Well, here's a proof. Look at this. Prove that if v is a vector of length L and C1 and C2 are the direction cosines of v, then so you actually have a little proof in here in chapter 2 on direction cosines. So normally you wouldn't even discuss those until maybe a calculus 3 class. That's when they come up, I know, in calculus. There's another proof there. Let's skip ahead to something a little different. How about graphs of polynomial functions? Yeah, those are interesting. I only have a few videos actually on this topic. Graphs of very few, maybe 2 or 3. Sketch the graphs of the polynomial functions given below. Okay. So yeah, these are pretty standard problems. Basically, you look at the zeros. So -1 and 1 are zeros. Those are the x-intercepts. So you plot those, then you look at the end behavior, and you do a rough sketch. You can do like a rough sketch of most of these without any calculus, but for a lot of these, to find to actually find like the maximum or the minimum, you'll need calculus skills. So when you learn graphing in like algebra classes and pre-calc classes, they never expect you to be perfect on those little maxes and mins usually, right? Usually that's the case, because normally you need calculus to do that. It's kind of fun just looking through the book. Let's jump ahead and see where else we go. It's kind of just exploring. Oh, trig identities. Yeah, I've done some of these actually. I think I did like 1 or 2 of these for my YouTube channel in Spanish. I was just messing around with the book. I just picked 2. It smells really good. Yeah, tons of practice problems. How about the solutions? Let's take a look at that. So let's see what is going on with the solutions. I'm pretty sure you just have answers to odd number. Yeah, odd numbered exercises. So that's all we have here. So you don't have full solutions, odd numbered, which is pretty standard for some reason. Here it talks about matrices and determinants. Yeah, I think I looked at this part of the book for some reason. I was looking at this. Yeah, cool. Cool stuff, right? So here's second order determinants. So that's pretty easy, right? You just multiply a1 times b2, you subtract and you multiply those. That's how you define the determinant of a 2 by 2. And then for like, once the matrix gets bigger, it's harder to find the determinant. So you use other, here we go, third order. They give you a formula. You could memorize it, I guess. There's better ways to memorize than that. That's not really that helpful. I mean, I guess you could memorize that. I don't. Some people do. Some people do. I don't. I just use cofactor expansion. I think here they're going to introduce that because they're talking about the minor. So it's part of that process. Yeah, so if you take a pre-calc class, you'll see this stuff. It's pretty cool. Yeah, awesome. Then they have some exercises here. Kramer's rule. I always think of Seinfeld, but that's Kramer with a K in Seinfeld. So these are 3 by 3 systems of Kramer's rule. So, a little more work. Look at that. So that's here. So here's Kramer's rule for 3 by 3 systems. And so basically, you have this system of equations. And to find the solutions, which you can find as long as the determinant of the coefficients is non-zero, that's what you see down here, because you can't divide by 0. If that's the case, if it's not 0, then there exists a unique solution to the system of equations, and it's given by these formulas. And that's called Kramer's rule. It just calls it 3A4. It doesn't really, but this is Kramer's rule. Okay, for systems of equations with 3 equations and 3 unknowns. It's usually easier to just do the 2 by 2 case. So yeah, so you have to find four 3 by 3 determinants to come up with the solution. So it's pretty wicked. Yeah, cool stuff. I guess they go through a proof of Kramer's rule here. Nice. I mean, pretty heavy book. Really heavy book. It's got a lot of hardcore content. It's got a really cool section on. Let me just show you. It talks about the wrapping function, and that comes up in another form. Okay, in another form. In the study of complex analysis or complex variables. If you took a course on complex variables, perhaps the book you are using would call it that way. The wrapping function, intuitive description, it's really interesting that they put this in this book because it's not something I expected. Here they talk about it. It starts here. Yeah, intuitive description. It talks about the idea behind the wrapping function. Here's a nice picture. The above describes the wrapping function phi. The domain of phi is the set of real numbers, and the range of phi is the set of points on the circle whose radius is 1. It has a picture here. So I'll try to give you some intuition behind it. But a lot of the things in math, one of the things I like about math and math books, because I have a lot of books and I'm always reviewing books and stuff and doing problems, is that it's fun to look at different books and you see reoccurring themes come up in various areas of math. And so I think that's cool. When you start seeing those things, you start seeing like, hey, this comes up in this field, and it's very similar to this, which is taught this way in another book, but they're unrelated, but the process is similar. So it's always cool when you see stuff like that. Anyways, really cool book. I just wanted to sit down and make this random video and show you this really cool book. I hope this video has been enjoyable. Good luck.